What up, Algebra 2 students? This is Mr. Shack, and this is your first review video of the year for Algebra 2, our Module 1 review video. So what you're going to see with every video, or every review, I should say, I'm going to make a video for every review. But the main thing with doing this review is you need to be sure that you're using it in the correct way. Now, you don't want to use this as a way of just, oh, okay, you're teaching it to me, I better copy it down like notes. No, that's not the style of this. This has already been taught to you, so you need to be sure that you are trying this on your own and then checking your answers with my video, checking your thought process with my explanation, those types of things. So very important that our volume is up, and I'm writing it just in case some of you are listening to this in silence. That way you know that that volume needs to be up, and if you did start this listening to it in silence, you want to restart it right now so you can hear how I was explaining how you need to be using this review video. Okay, so with that being said, make sure you listen to that intro if you haven't, so you know how you're going through this, how you're using this in a way that's going to be most beneficial to you. Because remember, this review is not graded. This is not even a homework grade. You need to understand these types of problems to make sure you are ready for your test, which if you're watching this, it's probably tomorrow that you're taking the test. Okay, so getting going right away, if we're stating the end behavior, as x approaches positive infinity, notice it doesn't say negative, as x approaches infinity, what is our function approaching? Well, our function, as we're going right on the graph, because as x is approaching positive infinity, our curve is also going up to positive infinity. Okay, f of x is going all the way up to positive infinity. Now, as we're going to negative infinity, as we go left on our x-axis, well, what is our curve doing? What is our function doing? F of x is going all the way up to positive infinity once again. Okay, as x approaches infinity over here, what is f of x doing? Well, as we go right on our graph, what is our function doing? Oh, it's going down to negative infinity. Okay, as x approaches negative infinity, that means as we go left on our graph, as our x values are getting smaller and smaller, what is our function doing? Well, it's getting bigger and bigger as we go left, so that's why it's approaching positive infinity. Okay, moving on to number 2, if we have something like this, and we're to describe the domain and range of the function in set builder notation. Okay, the set builder notation is when we have the squiggly lines. If we're talking domain, we're talking x, so we say x such that, well, what is our domain in this case? Is every value to the left going to be hit? Well, yeah, it looks like it'll go left forever. Is it going to go right forever? Yeah, it looks like it's going to hit every value of x left and right. If we were to zoom out, it's going to keep continuing to go left a little bit, right a little bit. So yeah, it is going to hit all real numbers. Our domain is x is an element of all real numbers. Okay, that's how this is written. X is an element of all real numbers, meaning our domain is all real numbers. It's going to hit everything. Okay, now our range, if we're talking range, we're talking y, or f of x. Maybe I should even write it as f of x, because a lot of times your book will write it as f of x. So let's say f of x such that, okay, well, what's going on with our range? What y values are we hitting? Well, we're hitting 2, and everything below it, it looks like it's going to go down forever. Is it ever going to be up here? No, it's not. So it's f of x such that f of x is always going to be less than, does it hit 2? Yeah, it does. So less than or equal to 2. That's going to be our range. Okay. And again, just in case you haven't been using this video the right way, you should have already done this, and then you're checking your thought process, checking your answer with me and my explanation. My answers, my explanation is what you're checking it with then. Okay, so now if you haven't yet done one on your own, try to do this next one on your own, part A and part B, and then watch the video, hit play again on the video once you've done this on your own. If you haven't done it yet, hit pause right now to do that. Okay, now state the domain and range for the given function in interval and set builder notation. Okay, so I guess we'll start with set builder. If we're talking domain, we're talking our x values. So what is x hitting? Well, we're talking our horizontal values that our graph is hitting. So it's going to hit our left over here where x is 0, and it goes over to where x is 5. That's where it stops. Okay, so 0 is our low bound, right? That's the lowest x we hit. 5 is our high bound. That's the highest x we hit. So that means x is greater than 0. Does it contain 0? Since this is a filled in dot, that means yes, it can equal 0. Can it equal 5? That's an open dot, which means it does not contain 5. X is less than 5. Okay, now if we're going to put that into interval notation, since it's asking for both, okay, well, again, it contains the 0. So we have a bracket. Our other bound is 5. It does not contain the 5, so we have a parenthesis. Okay, very important that we realize why this is a bracket, why this is a parenthesis. Bracket means it contains it. Parenthesis means it does not contain it, but it gets all the way up to 5. Okay. Now range, again, when we're talking range, we're talking y or f of x. So I guess I'll call it f of x again. Remember, f of x and y have the exact same meaning. Okay, f of x is just a fancier way of writing y. So what y values are being hit? Now we're talking up and down values. How low does it get? How high does it get? Well, our upper bound is definitely 6. Our low bound is definitely 1. So our low bound 1, high bound 6. And again, we're talking f of x for range. It has to be greater than 1. Can it equal 1? No, it cannot, right? Because it has an open circle there, so it cannot equal 1. Now, what about the high bound? Does it contain the high bound? Yes, it does, because it's a colored in dot, so that means less than or equal to 6. That was a terrible curly bracket. I suck at curly brackets in general. I'm sure you already know, so that is all right. We'll just keep moving on to interval notation now. Okay, so interval notation, again, it's the same bounds. It's 1 and 6. Do we contain the low bound of 1 here? It's an open circle, so no, we do not, so we write parenthesis. Do we contain our upper bound of our y value of 6? Yes, it's a filled in dot, so we contain the 6, and you need to write it like that. Okay, moving on now to describe the end behavior. Well, we always start it with this. As x approaches, what do we want to say x is approaching? Well, I guess x is approaching 5 as we go right on our graph. We can't say as x approaches infinity because it doesn't. So we say as x approaches our upper bound of 5, what is our function approaching? What is y approaching? What is f of x approaching? Well, let's see. As we go right, our function is approaching this y value of 1. So that's that. Now, if we're going to use now our low bound, as x approaches 0, so as we go left on our graph, what is our function approaching? What is our y value approaching? It's approaching 6. So f of x is approaching 6. Okay, as x approaches 0, y approaches 6. Our function is approaching 6. Okay, that is end behavior. Oops. Moving on. Okay, again, if at any time I'm going too fast, remember you have a rewind button, you have a pause button. It should be being used throughout this video, and know that I will go a little bit faster because I do have to make sure that this video is under the 30 minutes that I have in order to record it. Okay, here in number 4, we're given a function, negative x squared. It's being transformed to obtain the graph of the related function g of x using a vertical stretch factor of 3 and a vertical translation up 5. Okay, so what's our new function going to look like then? That's probably what we should figure out, and I guess they're calling it g of x, so I should probably call it g of x. Okay, again, it's negative x squared is what it is. If it's being stretched by a factor of 3, it's now going to become a negative 3x squared. And then a vertical translation up 5. That means plus 5, going up 5. Okay? Well, right away you can tell we're not going left or right at all. So I can plot my first one at 5. How do I know we're not going left or right at all? Because there's nothing being added or subtracted from x here. If there is something being added or subtracted from x, like in parentheses x plus 2 parentheses squared, well, then that would mean we have to move left or right a little bit. But nothing is happening to x. It's just being moved up 5. So that's how I know I have to go up here. Now, if you prefer to make a little x, y, t-chart, or x g of x t-chart, again, same thing as an xy t-chart. You could put in 0, you could put in -1, you could put in 1, see what you get. Well, we put in a 0. 0 squared times -3 is 0, because 0 squared is 0. 0 plus 5 is 5. Yeah, and that's where I plotted it. Now, -1 squared is 1. -3 times 1 is -3. -3 plus 5 is 2. So my next point is going to be at -1, comma 2. And I'll plot that there. Okay. And then another point here, we plug in 1. 1 squared is -3. Or I'm sorry, 1 squared is 1. -3 times 1 is the -3. -3 plus 5 is again 2. But we should know that right away because it's a parabola, so we know it's going to be symmetrical like this, and you can sketch it in. I might have even missed my dot a little bit, but this would be enough to show you understand the problem, you know what's going on. That's what I'm looking for, something like that on a problem like that. Okay. Number 5, we just need to place an X in what type of translations are happening. Are we translating down in this first case? If we have a minus 3.2, yes, that means we're going down 3.2. Are we moving left? X minus 4, you would think like, oh, minus 4, we're going left on the graph because that's where the negatives are. But remember, inside parentheses, what's happening to X, it's always the opposite of how it looks. So this is actually going to move it right 4. So check that box there. Now, from there, do we have any translation down here? No, because there's no plus or, well, it would have to be a minus if we're going down. A plus would bring it up, but if there was a minus out here like there is here, then we'd say translation down, but that's not happening here. Okay. What about translation to the left? This x plus 9. That plus 9 is going to move it left 9 because, again, it's in the parentheses. It's always the opposite of how it looks, so this plus 9 is going to move it left 9, making it a translation to the left. Well, and if it's moving to the left, it's definitely not moving to the right, so we're done there. Okay, translation down here. If this was a minus 1.3, it would be down, but since it's a plus 1.3 out back, that means it's going to move it up 1.3. So it's definitely not a translation down, and it's not going to move left or right either because nothing is happening to x inside the parentheses, so there's no box we can check on that last column. Okay, again, I'm moving a little fast. You have a pause button, you have a rewind button if something didn't make sense the first time around when listening, so please use those buttons. And again, try these on your own before I go ahead and give you the answer. So again, if you haven't yet, pause the video right now and try to do number 6 on your own. Okay, we are going to graph this function, negative absolute value of x plus 3 plus 1. Okay, well, from there, we can tell that our function is opposite of h comma k, or I guess you can think of it as h comma k. That's our vertex. Now, if we got an x plus 3, because remember how this is written, it's always a times f of x minus h plus k. Since we have a plus 3, that means h is really a negative 3 because it's like minus a negative 3 gives us that plus 3. Okay, so our x value is negative 3, and then our y value is a positive 1. So negative 3, 1 is our vertex. And now from there, really, is there a stretch factor? No, it's just 1, but it's a negative 1, so it's going to flip it upside down, so we need to recognize that. But other than that, we know absolute value functions then just have a slope of 1. In this case, it's a slope of negative 1 because of that negative out front. And then we can just sketch it in like this. Okay, and that's plenty to draw our graph. Okay, that's part 1. That's worth a good amount of points, and now this is just going to be 1 extra point if you can answer this question. Graphing is the very important part though now. And now based off that graph, if you've graphed it correctly, this part B should be very easy. So now which statement is correct? The function of f of x has the same x-intercept. No, they don't have the same x-intercept. They don't cross the x-axis at the same spot. What about the y-intercept? Nope, this one crosses here, this one crosses up here. Nope, they don't have either of these. You can cross them out if you like to eliminate answers. From there, function f of x has the same domain as g of x. Okay, well, the f of x domain, this is going to go all the way to the right, this is going to go all the way to the left, so it will hit every x value. This function has all real number domain. It's going to hit every x value, so negative infinity to positive infinity. What about this guy? This guy also will hit everything to the left, and it will go forever to the right also, so it's going to hit everything from negative infinity to positive infinity, so they do both have the same domain of all real numbers. Okay, do they have the same range? No, this one is going down, so it's the range is going to be f of x has to be less than 1, less than or equal to 1. In other words, y has to be less than or equal to 1. Well, in this range, it's going to be y has to be greater than -2. So definitely not the same range. So that's why C is your correct answer there. Moving on to the very last page here. In 7, we have quite a few things going on. Let's worry about one thing at a time. First, when are we increasing here on this graph? And it says state the intervals. So we're going to go interval notation. And remember, if we're increasing, that means as we read right to, oh my gosh, as we read left to right, I don't know anyone that reads right to left. As we read left to right, just like we'd read a book, whenever we're going uphill, that's when our graph is increasing. So we're going downhill, downhill, downhill. All of a sudden, we hit this hump at x equals 2. So 2 is going to be our bound. And then all the way from there on, we are going uphill. We are rising as we go from left to right. 2, yep, after we hit that x value of 2, we're constantly going up. So from 2 to positive infinity. We don't include 2 with the bracket because are we really increasing at 2? No, we're just changing direction at 2. From there on, we are increasing. Which means decreasing, well, yeah, everything left of 2. So in other words, all the way over here at negative infinity, okay, we're going downhill, 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 all the way till we hit 2. That's when we start going uphill. So from negative infinity to 2 is when we are decreasing. Again, if you needed to listen to that because you forgot how to do this type of problem, well then, okay, good. Now pause right now and try to answer then for g of x. Okay, pause if you haven't done g of x. Hopefully now you have done that and you can go ahead and listen to me now, okay? So if we're increasing, again, we have to be going uphill as we go from left to right. So here I come in from left going to right. I hit my graph. I'm going uphill, uphill, uphill until I get to right here at an x value of positive 2. So we're increasing this whole time as I come in because, again, we would expect this to go all the way out to the left. So we're increasing really from negative infinity all the way till we hit this x value of 2. Okay? And remember, the intervals of x, that's always what you're stating. From what x value are we increasing? From what x value to what x value are we increasing? Then what x value to what x value are we decreasing? Okay, so it's always intervals of x when we're talking increasing versus decreasing. Okay, so now our x value here is 2, and here we go, we're going downhill, 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 decreasing this entire time 2 on after. In other words, from 2 to positive infinity. And again, it's always what x value are we decreasing. Well, at 2, we're not doing anything. That's when we hit this turning point. And then all the way on after 2, that's when we're decreasing, decreasing, decreasing 2 all the way to positive infinity. Okay, lastly, part B, we have 2 questions about average rate of change. Okay, these are good questions, and we need to know if we're told what is the average rate of change on the interval -4 and -2. That means these are both x values. Okay, so in other words, I could go and I could say, okay, one of my x values is -4. I need to find the y value to go with that. Now my other x value is -2. I need to find the y value that goes with that. Then I'll have two ordered pairs, and then from there I can go ahead and plug it into my y2 minus y1 over x2 minus x1. That's how you find rate of change, like you would find slope, and that's stuff you've done for years. Since middle school, you found slope using y2 minus y1. In other words, you're changing y over change in x, over x2 minus x1. Okay, so to find, okay, well, what what y value goes with my x value of -4? Well, I go to -4 here, and I see what is my y when I'm at -4, and it looks to be at 3, -4, 3. Again, this is if I'm given the graph, but if you were given the function, you could just plug the -4 in for x. Say you had like I don't know, x squared plus 3. Well, then plug in negative 4. Negative 4 squared is 16 plus 3 is 19, so then your y is 19. That would be a way to plug it in if you were just given an equation like that. But in this case, we're given the graph and we can see it on there. Now, when x is negative 2, here's x at negative 2. What is our y value there? Oh, it looks to be at negative 1. So that's our other ordered pair. Now, from there, I just realized you couldn't see me pointing to the graph. But again, at negative 4, notice how our y value is up at 3. So that's where I got this one from. Okay, at negative 2, here we are. Our y value is at negative 1. That's where I got this ordered pair from. From here, I am using this y2 minus y1 over x2 minus x1 to find my rate of change. Okay, so y2 we'll call this x1, y1, x2, y2. Okay, so negative 1 minus 3. That's y2 minus y1 over x2 minus x1, negative 2 minus a negative 4. Okay, what does this equal? Well, negative 1 minus 3. So we're at negative 1. Take away 3 more. We're at negative 4. Now, negative 2 minus a negative 4. Remember, when you have minus a negative, it really becomes addition. So it's like negative 2 plus 4. So we get that over 2. Negative 4 over 2 can be reduced to simply negative 2. That's your average rate of change there. Okay. Now you do the exact same thing for this one, except now we're talking g of x, so we're using this graph here. Okay. And same exact thing. They're giving us the interval. Remember, this is an x to x interval. So when x is negative 1, we need to find the y value. And then when x is 2, we need to find the y value that goes with it. So we do the same thing. If we're given the graph, we can find that off the graph. If we're given the equation, well, then you plug this in for x and use PEMDAS to see what you get as your output. Okay, now if we are at a negative 1 x value, here we are. Well, what's our y value that goes with negative 1? This looks to be right at no, it doesn't. Negative 1 is right here. It looks to be right here at negative 2. Negative 1 is here. Negative 2 is what our function is going through when x is negative 2. So our y value is negative 2 right there. Now at positive 2, okay, here's positive 2. What's our y value there? It looks to be 7. So that's where I get that ordered pair from. Now again, then you're just plugging it into y2 minus y1 over x2 minus x1. If you haven't done that on your own yet, do it right now, and then hit the play button once you're done doing it on your own. If you haven't done it yet, pause right now, play once you've done it. Now, hopefully you've done it. Y2 minus y1, well, I'm going to call this x1, y1. I'll call this x2, y2. Y2 minus y1, so that's 7 minus a negative 2 over x2 minus x1, that's 2 minus a negative 1. Okay, well, what does this equal? Again, we're subtracting a negative. So 7 minus a negative 2 is like saying 7 plus 2, that is 9. 2 minus a negative 1, that is, just want to make sure I got the right points there. 2 minus a negative 1 is 3, because it's like 2 plus 1, so that's 3. So we get a rate of change of positive 3 there. Now, this one is really hard to see what we're going through at negative 1, but I do believe it is going through negative 2 there. So I would say it's 3. Okay. So that's the thought process there. Again, these are the types of problems you need to understand in order to do well on the test. These are the types of problems you should expect to see on your Module 1 test. Okay, so if you have a good understanding of how to do these problems on the review, you're sitting good, you're ready to go. If not, probably watch the video again, try to build your understanding up so that you're ready to go for the test when it comes around, when you're expected to do this type of stuff all on your own, without a video, obviously, without notes. But I think you all got this. Thank you for watching, and good luck on the assessment.